Now, previously we've looked at solving equations of waves. So when we've got an equation that is a combination of sines and causes, we've looked at solving them by combining these using one of the four variations of the wave equations that we've got, are k cos x plus alpha, k cos x minus alpha, k sin x plus alpha, k sin x minus alpha, and then solving this. What we're going to look at today is sketching graphs of waves where the waves initially got a form that combines cos and sine. So again, the same sort of thing, p cos x plus q sin x. What we're going to look at is writing this in using one of the four wave variants and then using that to sketch graphs of waves. Now, we've previously done videos on sketching graphs and transformations of graphs. So if you want a refresher, go back and look at those, because what we're going to do is we're going to focus on the technique for the graphs of waves today. And the best way to do that is with an example. So let's imagine I want to first write 7 cos x plus 6 sin x in the form k cos x minus alpha, where alpha is between 0 and 360 degrees. I'm then going to say, hence, sketch the graph when x is between 0 and 360 degrees. So it's a two-step process in this case. First one is I have to write the equation out. So 7 cos x plus 6 sin x in this form. We start the same way, expand the bracket. So expand our k cos x minus alpha. We know that's going to give us k cos alpha cos x plus k sin alpha sin x. It's going to give us those two forms there. And we know we equate it to the original function in order to figure out our coefficients. So now we're going to equate it to 7 cos x plus 6 sin x. And in this case, these two parts here equate to our two coefficients in this one. So k cos alpha equals the coefficient of cos x, which is 7. K sin alpha is the coefficient of sin x, which is 6. And then I know I can use that to get tan alpha sin over cos, which is 6 over 7. Now, think back to when we were using our cast diagram again. All three of these are positive, so I know I'm just going to do alpha is tan minus 1 of it, and I'll get my value that I'm going to put in the equation. So tan minus 1 of 6 over 7, when I calculate that, that gives me 40.6 degrees to 1 decimal place. We then have to look for the k part of it, and we know that k is equal to the square root of p squared plus q squared. P and q are the coefficients of the original equation. So in this case, k equals square root of 7 squared plus 6 squared. 7 squared is 49. 6 sixes are 36. When you square them and add them together, k is equal to the square root of 85. So now we've got the two parts we need. We've got the k, we've got the alpha, we substitute it all together. We say, fine, so 7 cos x plus 6 sin x can be rewritten as one trig function by saying that it's equal to the square root of 85 cos x minus alpha, which is x minus the 40.6 degrees. So we've rewritten it in this form. So we've rewritten it how we want the k cos x minus alpha. The second part is hence sketch the graph between 0 and 360. So when we're sketching the graph, remember we have to look at the different ways it was transformed. So if we look at the various parts we've got here, we're not adding anything on afterwards, so we don't need to worry about shifting up or down in the y direction. Great. We've got a root 85 at the front, so what that's going to do is stretch our graph, and it's going to stretch its maximum value up to the square root of 85 and the minimum value down to negative root 85. So when we're plotting the graph, we know that those are going to be the maximum and minimum values we have to take into account and mark on when we're doing it. So our maximum value would be up here at root 85, and our minimum value would be down here at negative root 85. Now it's a case of focusing on these because we know when they occur in x. We know that this occurs at 0, this occurs at 180 degrees, and then back to 0 again. However, this here transforms our graph in the x direction. So that means we have to take that into account. Now, in this case, it's x minus 40.6 degrees. So remember, when we have something x minus something in here, what that does is it shifts the graph to the right by that one. Despite the fact we're taking away, it does the opposite, so it shifts it to the right. So everything shifts to the right by 40.6 degrees. So our graph, our maximum goes from here to somewhere about there. Our minimum goes from 180 across to there. And our second maximum, well, that's now beyond our limit of 360 degrees. Remember, that's as far as we want it to go. It goes from 360 degrees. That new limit now goes up to 400.6 degrees. So we don't need to worry about including that. So what then happens is we just follow the same general idea for our curve. So it comes up like that, comes down to there, comes back up and cuts the x-axis and ends up there. So it's not quite at root 85 at the top here, but it is at the bottom. However, one other key bit of information we can mark on is where these maxima and minima occur. We knew where they were before, we know what transformations happen, so we can give it its new values. This one was at 0 in terms of x, but it's shifted up by 40.6 to the 40.6 degrees. This one was at 180 degrees, it's shifted up by 40.6 to 220.6 degrees. So we're now able to say that. We're now able to say that that is roughly what the graph looks like of the function y equals 7 cos x plus 6 sin x. So we've done the graph transformation by first putting it in this form. This is how we have to approach a problem like this. We can't just instantly jump in with both feet with 7 cos x plus 6 sin x. All right, here we go, let's get the values for that. We have to put it in the simple form we know, which is some function in terms of cos or sine, and then look at the graph transformations here. Now this ends up being our case regardless of whether it's a simple transformation like we just did, or one that looks like this, where we've got something like 5 sin x minus 11 cos x in the form k sine of x minus alpha, and then sketching the graph of 5 sin x minus 11 cos x plus 2, so this extra added wee bit here in the end. But our general idea and our general steps remain the same. We want to take this and put it in as a function of either sine or cos on its own, without a combination of the two of them, and then we want to add on the transformation from there. So let's start by doing that. So we start with the fact we want to expand it and make it k sine of x minus alpha, and write that all out as we normally would. So we get k cos alpha sine x minus k sine alpha cos x. And we can equate that to the original function here. We know we're going to get 5 sine x minus 11 cos x. At this point, equate your coefficients as we would normally. So k cos alpha equals the 5, great, got that, minus k sine alpha equals minus 11. We've got to include the minuses here, the signs play a part. However, with this one, they're both negative. So the good thing is they cancel out. You'll get some scenarios where that's not the case and the negatives do come into play. Be very aware of that. So in this case, we're able to then just cancel them and say, fine, so k sine alpha is equal to 11. Take the ratio of the two, and we get the tan alpha is 11 over 5. Now, all three of them are positive, so if we look at our cast diagram, we know we're going to get the first quadrant, so we're going to get our answer to just doing tan minus 1 of 11 over 5. Once we do tan minus 1 of 11 over 5, we get alpha, and we get that that's equal to 40.6 degrees. We then want to find the k. Now we know k is our p squared plus q squared, and the p and q come from just the coefficients there. Now, because it's a squared, we can ignore the negative, because when you square a negative, you get a positive, so it's not going to play any impact anyway. So in this case, we're able to say that it's 5 squared plus 11 squared. So we know k is equal to the square root, 5 squared is 25, 11 squared is 121. So what that then means is that we get an answer of 146. So our k equals square root of 146. What we then do is combine the whole shebang and make it this one here. So what we can then say is fine, so 5 sine x minus 11 cos x equals k, so square root of 146 times our sine of x minus 40.6 degrees. So we've got our function written in this form. So we've done that first part. Now, hence, sketch the graph of this. That's where the interesting part comes in, because we know y equals 5 sine x minus 11 cos x plus 2. Well, we know a substitution for this part here. We know that we can write that in terms of this. This 2 is not included, so what that means is we write it as the square root of 146 sine of x minus 40.6 plus 2. So we've got a whole function here with this. Now, if we think again of graph transformations, plus 2 here is going to have an effect in the y direction. Think back to when we did that. Something on the end here adds 2, so it shifts everything up by 2 in the y direction. So, look at each part on its own. Let's break it down. So square root of 146 is going to stretch the curve up and down. Its maximum and minimum are going to go to square root of 146 negative 146, which is pretty much bang on 12.1, just a tiny wee bit off. Sine of x minus the 40.6 shifts the entire graph right in the x direction by 40.6 degrees, and then the plus 2 is going to shift the whole thing up 2 in the y direction. So instead of starting at 0, what we're going to do is we're going to start at 40.6, and then that's going to shift up to 2 just there. The rest of the graph is then going to shift and go to there, go up the top there, down underneath the 0, and to there. And it's not going to go right back to the x-axis. Remember, if it was repeating normally it would, but because we've shifted it off, it's not going to go right back to the x-axis at 360 degrees. So now we have to mark on our key bits of information. Well, we know we stretched it, so our height went up to square root of 146 down to negative square root of 146, but the plus 2 has shifted those up by 2. So our 12.08, which was our maximum, goes up to about 14.1 now. And our one which is down here at negative 12.1 goes up to about negative 10.1. Our zero intercept goes along to there, shifts along by 40.6 degrees in the x. Where our maximum was, it was at 90 degrees, remember. It shifted up by 40.6 again. So that has now gone up to 130.6. Our zero, which occurred at 180 degrees, has gone to 220.6 degrees. And our minimum, which occurred at 270 degrees, has gone on to 310.6 degrees. So this is us plotted the new graph. So a graph of y equals 5 sine x minus 11 cos x plus 2. So we're able to get all the key bits of information here. Now I know it doesn't look the neatest of diagrams, and it doesn't look like it's going to be the most displayed, but doing this makes it so much easier for us. It means that we're able to do these transformations in simple terms using the transformations from trig graphs and other graphs that we covered in previous videos. So just remember that, turn it into a wave function with a single trig function, then transform the graph, regardless of whether it's that on its own or whether it's with an extra bit here like at plus 2 at the start.